Hello, everyone, and welcome back. My name is Mr. Cobalt, and in this video, I will be talking about how to quantify entropy changes in the surroundings. So, in order to do that, we go back to when we were talking about the system in an earlier video. We're talking about how to do calculations of entropy changes of the system. So, when a system is exchanging energy with the surroundings, we saw that it changes the entropy of the surroundings, right? So if the system is releasing energy into the surroundings, then the system will tend to decrease its entropy while the surroundings increases its entropy, right? And then vice versa. If the system is absorbing energy from the surroundings, and the surroundings will kind of decrease their entropy while the system increases its entropy. So if we go back to that relationship, then we can see two things. One, the energy, the change in entropy of the surroundings depends on two things. One, the amount of energy transferred into or out of the surroundings, right? So that's, how much, the more energy I transfer to the surroundings, then the more energy that is there to dissipate and disperse into the vast environment or surroundings. The second thing is that the temperature of the surroundings, it depends on the temperature of the surroundings, and we saw that in my last video. So if we go back to the units of entropy, right? So remember the units of entropy is joules over Kelvin. So it makes sense. So if entropy depends on joules over Kelvin, if those are the units, then it makes sense that the entropy is going to depend on both of these factors. How much energy is transferred to the surroundings and at what temperature the surroundings is at. Okay, so in order to calculate that or to quantify the amount of entropy change in the surroundings, when we go back to our equation for the system. So here we had the change in entropy of the system was equal to the heat of the process of the reversible process that we had divided by the temperature. Okay, so this was for the system. And so when we're thinking about in terms of the surrounding, then we have to keep in mind the first law of thermodynamics, right? So the first law of thermodynamics says that the no energy is lost or created during any process. So the energy of the universe is constant. So that means that any energy that is lost or gained by the system is in turn gained or lost by the surroundings. So if I lose energy from my system, that's gained by the surroundings. If I gain energy into the system, that's lost by the surroundings. So that's why there's this negative sign there. So the negative just means that it's opposite. So whatever amount of energy I gain here, if this is positive, then the amount that the surrounding gets is negative. So the surrounding lost energy. If the energy of the system or the heat of the system is negative here, right, meaning that the system lost energy, then that was gained by the system. So then that's going to be a negative times a negative. That's going to make this positive. So that just means that these are opposites of each other according to the first law of thermodynamics. So what's lost by one is gained by the other. What's gained by one is lost by the other. Okay, so if the amount of heat, like say exchanged or with the system, that's going to be the negative of Q of the surroundings, and that's just going to be the negative delta H of the system. Since the surroundings is so vast, it's a vast pool of energy and molecules and things like that. So that's going to be under constant temperature, constant pressure. So the only exchange is going to be with the system. So the only heat exchange is the system. So whatever is lost by the system, we're assuming that's going to be gained by the surroundings. So here we have our equation for the change in entropy of the surroundings. That's going to be negative delta H of the system. So again, the heat of the surroundings is the opposite of the system. So we have negative delta H of the system divided by temperature again. And again, this is going to be at constant temperature and pressure. So there's three things to notice here. First thing to notice is that a process that emits heat, right? So this system is the process that emits heat into the surroundings. That means that delta H of the system is negative, right? So it's losing heat. This is going to increase the entropy of the surroundings. We saw that before. So heat that's released from an exothermic reaction, heat that's released to the surroundings, that heat dissipates, and therefore we have this dispersal or randomization of heat into the surroundings. So that's going to increase the entropy of the surroundings. And then we have the opposite, a process that absorbs, again, this endothermic process, absorbs heat from the surroundings. That means that delta H of the system is greater than zero. It's absorbing heat from the surroundings, so it's gaining heat. That's going to decrease the entropy of the surroundings. So the delta H, or I'm sorry, the delta S of the surroundings is going to be greater than or less than zero. Okay. And the third thing to remember is that the magnitude of the change in the entropy of the surroundings is proportional to the magnitude of the change in the heat of the system. Okay, so the larger the amount of heat change in the system, again, that's being transferred to and from the surroundings. That magnitude is going to determine the magnitude of the change in the entropy of the surroundings. So more heat exchanged with the surroundings, more heat exchanged with the surroundings from the system, the greater the magnitude of the entropy. Okay, and so again, that's going to be temperature dependent. And so I think that's it for this video. So I hope you enjoyed this video. If you like this video, if this helped clarify things for you, then please, by all means, hit that like button right there. And don't forget to subscribe to my channel. Hit that notification bell right up there. And also put a comment down in the comment section. Let me know what you think. If you have any questions, let me hear them. Thanks for joining me, and have a great day.